This is exercise set 6.3, the last homework problems in chapter 6, the last homework problems before the exam. Now, this is not derivation like the ones we've been doing. This is a little different. And the reason for this, or one of the reasons for this, is to show you that the rules that we've been learning and derivations can be used for more than just proving that an argument is valid. That's what we've been doing so far, is looking at arguments, deriving the conclusion from the premises by using these rules, and thereby showing their valid arguments. But if you think back to truth tables, we did a lot of things with truth tables. We tested whether sentences were consistent, whether they're equivalent, whether they're tautologies, contradictions, contingent, things like that. And you can use these rules we've been learning. You know, this is the derived inference rules and substitution rules, and then there's all the introduction and elimination rules from chapter 5. You can use all those rules to do similar things. So we're not going to get a chance to do all of them, but exercise set 6.3 at least shows you how to do one of them, namely prove that a sentence is a tautology. And the way you do that with derivation rules is you derive it from no premises. All right. Now, a tautology, if you remember, is a sentence that always has the value true, meaning it always comes out as true. And so if it always comes out true, you should be able to derive it from no premises. Now, of course, you can't really derive something from no premises, right? You need something. And that's why we're going to be using for these either the conditional introduction rule or one of the negation rules, because those rules allow you to make assumptions, and those assumptions then can get you started on your derivation. So exercise set 6.3 then is proving that a sentence is a tautology by deriving it from no premises. Now, the sentences that you're given, I'm doing the even ones here, the odd ones are homework, but this is what you're given. Like if you look at the book, it says number 2 and it says this. And one thing that's a little confusing is sometimes students think that's a premise, but that's not a premise. It's the conclusion you have to derive from no premises. So put the 3 dot symbol next to it. Don't number it. It's not a numbered premise. It's what we need to get to stop the derivation. So again, how do we prove something from no premises? Well, you have to make an assumption. So you have to use one of the rules that allows you to make assumptions. All right. So we'll tab to indent, and we'll assume, since this is a conditional that we're trying to derive, we'll assume the antecedent and want the consequent. Okay, so we have F, we want F, then G. And hopefully you can see that it's very easy to derive F or G if you have F. Namely, you just use the disjunction introduction rule on line 1. Right? The disjunction introduction rule says any sentence you have can be put into a disjunction with any other sentence. Because if F is true, then we know F or G is going to be true. And so that's it. We got what we wanted. Go back to the original scope line. If F, then F or G by conditional introduction of 1-2. So it's that simple. Now, since we derived this sentence from no premises, we have thereby proved that this sentence is a tautology. Okay. So the instructions say on a separate piece of paper, construct a proof that shows each of the following sentences of SL is a tautology. So that's what we just did by deriving it from no premises. Okay, so if we look at number 4, our conclusion here is a biconditional. P biconditional P. And again, as I mentioned in the 6.2 exercise, generally a good strategy for deriving a biconditional is to derive the 2 conditionals. Right? So this is going to be, so we'll start by indenting P want P. And we can very easily get P by R reiterating 1. Right, so that gives us then P conditional P by conditional introduction 1/2. Right? Now, since a condition or a biconditional is a conjunction of two conditionals, right? We do need to get P, but we can get that by reiteration of 3. And so now we can get P biconditional P by biconditional introduction of 3 and 4. It's a little weird because the antecedent and consequent are the same there, and so the two conditionals that make up the biconditional are the same. But you have to have both of them. That's why I did both lines 3 and 4. Okay, so now let's go to 6. Okay, again, this is the sentence we're given in 6, and remember, it's not a premise. Don't number it. Don't use it. That's what you need to get to. It's a conditional. So again, conditional introduction should suggest itself. So S want V and not V, conditional W. Okay, now this second thing is a conditional too, the thing we want. So again, we can indent again, and we can do V and not V as our assumption, want W. Okay, so now we need to go from V and not V to W. So there's a couple ways you could do this. You could do assume not W, in other words, do a reductio, right? Because you already have the contradiction. You just need to do conjunction elimination to get it, right? But you could also derive it without reductio. So let me do without the reductio first, and then maybe if I have time, I'll come back and do it with reductio. So you get V by conjunction elimination of 2. Then you can get V or W by disjunction introduction of 3. You get not V by conjunction elimination of 2. And now you can get W by disjunction elimination of 4 and 5. Okay, so that's what we wanted. We assumed this, we wanted W, so we're done. So we come back to the previous scope line, and we write V and not V conditional W. It's by conditional introduction of 2 through 6, right? 2 is where we assumed the antecedent, 6 is where we got the consequent, okay? So now we assumed S and we got this, so now we come back all the way to this scope line, and we get S conditional V and not V conditional W. And that's conditional introduction 1 through 7. So line 1 we assume the antecedent S, line 7 we derive the consequent, so conditional introduction lines 1 through 7. Okay, so like I said, that's one way. You could have done it. Let me show you how to do it with the reductio. So if you do a reductio, you again have to do another indentation. And you assume not W for reductio. And you simply do get V by conjunction elimination of 2. You get not V conjunction elimination of 2. So that's your contradiction. So you come back here and you get W, and that's by negation elimination of 3 through 5, right? So our assumption had a negation, so by showing that not W leads to a contradiction, we prove that not W is false, and therefore W must be true. And then that gives us the W that we wanted, so we come back to this scope line and we say if V and not V, then W by 2 through 6. And then our last line is back to this original scope line. S conditional and not V conditional W. And that's again conditional introduction 1 through 7. So either of those is perfectly acceptable, and you can see they take the same number of steps, so it's not even like one is quicker than the other. Okay, last one is 8. I'll try to do this before my time runs out. It's a conditional, the conclusion. So again, tab to indent, assume the antecedent, and want the consequent. Not B, then G, then B. Oops, I need that. Okay, so we assume G, we want this. Now you can see what we want here is also a conditional. So again, we can tab in again, assume the antecedent, not B, then not G, and want the consequent. So again, this is called a nested conditional introduction or nested subderivation. The first one we did, we assumed the antecedent, derived the consequent, or wanted the consequent. The thing we want is a conditional, so now we just do a conditional introduction to get that. And it's the same process, you just have to indent one more time. Assume the antecedent here and want the consequent. Alright, so now we've got 2 things to work with, and we started with 0 things to work with, right? So we're in much better shape. So now how do we do this? Well, we have not B conditional, not G, so if we had the negation of the consequent, we could get the negation of the antecedent. But we don't have that, we have G, but as you remember from the double negation rule, we can get not G if we double negate G. Now we can do the modus tollens rule to get not B, modus tollens of 2 and 3. Modus tollens says if you have a conditional and the negation of the consequent, you can get the negation of the antecedent. The antecedent is not B, so the negation of the antecedent is not B. Now what we want is just plain old B. So now we do the double negation step. Oops. Dn on 4 to get B. Remember, the substitution rules work 2 ways. You can either add 2 negations to a sentence, which is what we did here. We added 2 negations to G. Or you can take 2 negations away, which is what we did here. We took the 2 negations off of B. So that's what we wanted, right? So that first, or the inside subderivation is done. We got not B, then not G, conditional B. And we got that by conditional introduction of 2 through 5. Now that's what we wanted from our first one, so we come all the way back to the original scope line. And again, that's by conditional introduction 1 through 6. Okay, so again, this is all done with no premises, right? These are assumptions you make, but they're not premises, right? We're not sure if they're true or not. But we do prove this final sentence. We prove it from no premises, which again proves that it's a tautology. Okay, so I hope that helps with the odd numbered problems. Again, there's other things you can do with these rules as well, consistency, equivalence, etc. But tautologies are just about all we're going to get